It's my pleasure to introduce Hamsa, a seasoned design professional with over 25 years of experience. From working with renowned architectural firm to founding Preset Building System Private Limited, his journey is marked by a unique blend of expertise. Beyond his professional achievements, his personal experience as a studio potter, musician, and martial artist have shaped his visionary approach to solving challenges in construction industry. Hamsa will present a talk on role of prefabricated solution in adding efficiency to the construction industry. So let's warmly welcome Hamsa.
So you might think, okay, there is something called construction technology. So, but when you see this presentation, you'll see that there has not been much progress in the technology. Of course, technology is there, but they're all so old, we wouldn't call them technology if it were any other field. Right. Okay, starting from the very beginning, we started some 2 lakh years ago, and coming out of the caves, we needed to build, so we used wood. Obviously, that was the most ubiquitous, easily available material. Just stretch your hand and you get wood. So our ancestors used wood and animal skin, rocks, straw, thatch, this kind of thing. So this happened some 1,000 years ago, right? But if you travel around the countryside, you will see these houses even today. Have you not seen these kind of things? People live in these kind of houses. So this is the continuous connection we have to the past. This is amazing because I'm talking about when people just tentatively stepped out of the caves and became wanderers to today when we are flying in jets and landing on moon. We still live, some of us still live like how our ancestors lived. The move happened. Another material that is very popular in construction is stone, because obviously it is hard, it is all over the place, and with the invention of metal tools to break the stone into shapes, it was an easy step to go into making strong buildings using stones. The very old ones are obviously just stone stacked together to fabulous, fantastic poetry in stone, our marble Jain temples and carved stone temples of South India and all over the world. And this is one of the largest stone building in the world. And this is in Philadelphia. It's almost 550 feet high. That's huge, right? So stone has been used from ancient time to modern time. Timber in a more engineered way is being used today as it is being offered as one of the cutting edge technologies. They call cross-laminated timber and other kind of engineered timber. We call it cutting edge. If you go back, our ancestors who were just come out of cage were using it. So there is connected to the longest past we can go to. So wood, albeit it is counterintuitive, is one of the most, I would say, the most environmentally friendly material to be used, because we can grow them. That's it, right? So all kind of buildings have been used, made using palaces to multi-story buildings to the most modern kind of buildings. So this looks similar to what Rahul would do with his technology, right? Yeah. Then came bricks. How old was that? It was just basically mud shaped by hand and dried in the sun, and then use them to stack, or the mud itself was stacked. So this is called adobe. Adobe means sun-dried clay. So when the dried clay was fired, we got the red bricks, the terracotta bricks. Like I mentioned earlier, terracotta bricks looks fabulous, looks natural, oh ma, and all that, but it is a synthetic material. It will never ever go back to being a soil. It will never be soil, right? It is transformed at a molecular level. So of course, beautiful bricks can be shaped. You can carve it, you can shape it, you can model it. So you can see the world's best brick buildings are here in our country. Go to Orissa, right? Places like this, fabulous. And West Bengal. So you have all these places, the Konark temples and all that, made of terracotta. The fired brick literally took over the construction field for a long time. from bricks to tiles to even large in the West when they made this fabulous big banks and other fabulous stately buildings. Many of those things that you see are they look like they are carved out of stone, but they were actually terracotta, molded terracotta, fired and then painted. So from a distance, it will not, you won't know whether it is terracotta or stone made. So many of the British European buildings, they were all, even the big fabulous pillars were all made of clay. And which is the biggest building in bricks? This is a 16-story building, 16 floors. This is before all the other technology came, steel and all came. So the room at the bottom, the floor at the bottom, the walls are 6 feet thick. The thickness of each wall. So the rooms were really narrow and hardly it looked like a cave. And going up, they reduced it. Even then, even the top floor had 1.5 feet thick walls. So, but they stretched it because they couldn't think of another way of doing it. Then there was a big breakthrough. 2 breakthroughs happened. One is steel. They started using steel, which suddenly gave them a freedom to scrape the skies. So that's where the word skyscraper came, right? Now we could reach out to the sky and touch the sky. So that initially, in fact, for example, here, this is one of the first tall building, 10 stories made with steel. The authorities came and stopped the work in between, saying, oh my God, this is not going to stay. So they had to do a lot of back and forth, and engineers had to come and convince them to continue. Now, of course, we build hundreds of floors using that, right? Then the next breakthrough is RCC. But remember, the R in RCC is steel. Yeah, which means there is no RCC without steel. You can't have a beam even of any length unless there are steel inside. The steel is what is stopping it from breaking it down like this. Because concrete is very strong in compression, very, very weak in tension. So you can easily break it like this, but you can never really press it hard. Yeah, so that is the strength. But here is a fun fact. RCC was patented as a material for, hold your breath, boats, not for buildings, for canoes. And they built ships during the World War. Suddenly they found steel is not enough steel is being made. And they started making ships with RCC. Look at these ships. It's so big. It's made of RCC. It's floating. Can you believe it? Most of you have never seen this. You can please Google concrete ships. Here are some of the old concrete ships still floating in the seas. You can see the reinforcement, right? Yeah. So steel makes cement what it is. So basically, I would say the one material that is the king of all materials is steel, because it's also one of the only material that can be 100% recycled, because you can melt it, right? So look at that ship, fabulous. Some of the notable buildings in steel, completely concrete buildings are there. These are called slip form. Now they call it Maiwan because there's a company that promotes the mold that is made of aluminum. But even way before that, these are all been made. So there is nothing new about any of the technology that you see. If somebody says latest technology and all that, yeah, right. Look at the dates. 1848. Somebody, Jean-Louis Lombard, patented this concrete. And look at this. 6500 BC is when cement was used. Right? Everything is ancient. And then comes most modern 3D printing. Also ancient. Look at this video made in 1932. 3D printing, 1932. Yes. So 3D printing is a funny technology, I would say. It is like making a horse go faster by putting some electrodes into its body or something like that. Because basically the technology itself has not changed. It is still making the wall on the site with a wet mix of cement. Instead of a human being pouring the concrete, a nozzle pours the concrete. I don't consider this as anything fabulous or anything like that, but it has its usages, especially when you make sculptural walls with textures, which will take a long time and a lot of skill for other people to do. 3D printing is a fabulous alternative to make temples and mosques and churches probably, or very sculptural modern buildings, curves, etc. Even now, it can't make a lintel, it can't cross over a window, it can't make roof, because it can't pour concrete on the air, right? And it can't make plumbing, it can't plaster it, you can't put windows. So it's very, very limited. It's basically hand making of the wall using a machine. Then comes prefabrication. So prefabrication, please again understand, we keep using the word prefabricated technology. I am telling you, being in the prefabrication construction technology for my own company, I started in 2015. That means at least 8 years, 9 years of experience I have of my own company. I'm telling you, there is no such thing called prefab technology. Every building is prefabricated, including the pyramid. Anywhere when you bring a pre-made element from outside the site and use it, that element becomes a prefabricated element in the construction. If you bring a window from somewhere, that element is a prefabricated element. So prefabrication is not a technology, it's a percentage. How much of prefabrication is happening and how much of fabrication is happening on site. So it's only a percentage. Except for Rahul's buildings, which is pre-designed, predetermined models. That means he can make them in his factory and then transport them. I would say, at least from the time when you look at it from coming out of his factory, what happens inside the factory is still handwork. But let us not go into that. Suppose we see Rahul's factory door is opening and something is coming out, and then it is going somewhere and then it is being assembled. That has a very high percentage of prefabrication, because the site work is very little. I would say it would be around 80%, 75 to 80%. Rahul can correct me, because he still has to do a lot of cladding, tile fixing, this now. So 70-80% is the maximum. That is about the maximum prefabrication we have been able to do in the whole world, other than bringing the whole building fully finished and dropping it. That can only be possible for tiny homes, not for buildings. So prefabrication is a game where we try to increase the element of prefabricated material as much as possible. I can tell you, none of the technologies in the world, except for Rahul's and other ready-made houses, has crossed even 50% of prefabrication. 3D printing, I would rate it as around 30% prefabrication, right? Anyway, so LGSF, like what Rahul is using, is a offspring of wooden construction, wooden stick built, or wooden, they're using wooden studs, wooden reapers, right? So this kind of construction is very popular in the Europe, and then it went to America. It's almost all houses in America are made like this. When this wood was replaced by a galvanized steel, this became more popular because now it can be used anywhere else, right? So there is a machine that rolls out these channels, which replaces the wood with the galvanized steel, and this can be used for making beautiful projects. By the way, this building here is an LGSF building. You can see the frame here. This is designed and built by my company. This is my project, right? So we can make fabulous, beautiful buildings of any nature using this type. But this prefabrication percentage would be only 30-40%. That's all. So it's a lot of hand. It just took 7 months, 8 months to make it. Then there is precast, which is basically 3D printing of another kind, where you pour concrete, let it settle. It's very heavy. Each of these panels will be 10 tons, 20 tons, 30 tons, and need a big cranes like this to lift. From the factory itself, it is very heavy. You need big lorries and to bring them, and then you put them together, but it's still not finished. You still have to do wiring, painting, tiling, all the stuff it has been done. But the percentage of prefab is high here because the walls come fully built, right? And then there is 3D. So instead of doing only wall by wall, if the rooms are small enough to be carried, the entire room can be cast in the mold, and these are called volumetric 3-dimensional precast, blah blah blah. Okay, so it's volumetric module, the whole volume. But you can see it doesn't have wiring, it doesn't have windows, doesn't have flooring, doesn't have many things. So a lot of work is still done. It just looks like a bare thing, but still, if you can transport it, or if the molding is done in the site, next door to the site, then this is the feasible method for fast construction. But even here, the prefabrication has not probably exceeded 30 to 40%. Then comes completely fitted boxes, which are fully finished with the roof, with the window, with the wiring, and you put them together like this, or bring the entire damn house on a lorry. This can't be done in India, as you know. We don't have roads like this. So these are called extra wide body carriers. These require 2 policemen in the front, 2 policemen at the back, and all that to stop all traffic. Special permission is required. Only in few places these are allowed. So this is an entirely built. This prefabrication is close to 100%, right? So this would be close to 90%. This is also pretty close, more than 70%, because here what they're doing is these are volumetric, fully finished, fitted with windows, fitted with all the things. They're just dropping them together and then connecting them. So these are called volumetric modular construction. This is as close as we can get to this. So what is next? What have I done? What is my company done? Preset. So what we have done is we have innovated a technology that covers architecture, costing, and construction without labor. So what we have done is we have developed a technology where buildings can be built without construction. So construction is the problem, remove construction. Pollution is the problem, remove pollution as much as possible. Skilled labor is a problem, remove skilled labor. Designing is a problem, remove designing. Give them a tool to design. So we have developed an app where the customer himself can create any design, no restrictions. Like Lavina was saying, or Rahul was saying, his offering is limited. Whereas here, you can create your own design, unlimited, horizontally, any number of rooms, any number of floors. And I'm even selling any number of floors, up to 5 to 10 floors, or even more can be done. So it's very easy. Here is the technology for you. It starts with the base. There will be a technology wherein there is an app with which you can configure the design of the building. It can be a house, it can be a school, it can be a hospital, hostel. You can move the walls around and create any design, any size, right? So these are the technologies that we have developed. And here is a visualization of how a house could be built. So within days, we have our system coming up. There is a skeleton. That's why we have full flexibility, which takes the weight and the load. And there are wall panels that come and fit onto this skeletal system, structural system. And they come pre-finished, pre-fitted, pre-painted. All you have to do is assemble. So a 3-bedroom house like this can be made in about a month, completely from the ground to up, ready to move in. So this is the technology. Unlimited choice of finishes. You can choose whatever type of walls you want, etc. And it is the fastest construction with 100% flexibility in design. No longer you are restricted to what somebody is offering. You can design yourself, whatever you like, or your architect can design. And whatever you design, we will deliver it as if it were a completely prefabricated. We have achieved a prefabrication level of over 80%, up to even 90%. So only assembly is required, no construction, no mason, no plumber, no painter, no carpenter, no electrician required at all. That is preset for you, right? So this is the 3 years of lot of magajmari and brain work that has resulted in this.
Thank you, Hamsa for sharing that exciting submission on prefabricated solution and showing its journey from the Stone Age till now.